Hello everyone, in this video I'm going to show how to use linear probability model and logistic regression to predict customers' purchase decision. And on the screen you see the purchase data. Purchase data is equal to 1 if the customer purchases a product from Under Armour store. And you have the purchase as the response variable and age is your predictor. So first we are going to use linear probability model. And for linear probability model, we will use data and data analysis and regression. We select input Y range, purchase, and then X is age. Since the first row is header, we click on labels, and for output range, we choose K1 and then click OK. Now, as you see on the screen, our model is the coefficient estimates. Let's highlight them. So this is intercept plus h slope times h is our model. In order to predict the probability of purchasing, predicted probability, we will use, first we take the intercept and then the slope coefficient times h. In this case, it's 20 years old. And then enter. So 20 years old customer has the predicted probability of purchasing a product from the store is 44.6%. And for 30-year-old, we will do the same. This is our model, plus times 30 this time. This is the linear probability model. In question 2, we will do the same analysis, but this time we are going to use logistic regression. Logistic regression cannot be done by Excel, so we are going to utilize data mining or analytics solver program. So first click on data mining and here choose classify, and the third option is logistic regression. We need to first determine the data range. And next, first row contains headers is going to be clicked. And here the output variable is the purchase and age is our predictor. And success cutoff is 0.5 and we click on next. Now we don't need variance covariance metrics, and here we click on next and then finish. Log-Reg output contains the coefficient estimates. We need this coefficient estimates in order to predict. So I'm copy pasting this here. Now I can predict the probabilities. Here I'm going to predict the probabilities, but if you remember from the course lectures, logistic regression is not a linear model. It's not a plus b times x. You have to use a special function, and that function starts with exponential. In the numerator you have e to the power a plus bx. In this case a represents intercept, so I select intercept from here, and then b is the slope coefficient of h times the age. And in the denominator you have 1 plus the same function, exponential, in the parentheses, a plus b times 20, and then close the parentheses and enter. So you see on the screen the predicted probability. It is 46.9% for a 20 years old customer to purchase a product from this store. We can do the same thing for 30 years old. We are going to use the same function, exponential, a plus g3 plus g4 times 30 this time, and divided by 1 plus exponential g3 plus g4 times 30, and close the parentheses. So the predicted probability for 30 years old customer is 20.7% to purchase a product from this store. And next we are going to use a holdout method. For holdout method, we know that the first 20 observations are the training set and the remaining 10 observation is going to be the validation set. So we construct the model, we find the coefficient estimates, and then we are going to use this coefficient estimates to predict outcome in the validation dataset. Let's first construct a model. For linear probability model, we are going to use data, data analysis, and here regression. And as you see here, the entire data set is selected, but in this case, I'm not going to select the entire data set. I'm going to select only the training data set. And for X input, the same idea. I'm going to select the first 20 observations, and labels are in the first row, and output range, let's choose a place. Let's put it here, L1, and then click OK. Now you can see here on the screen, this is our model. Now I'm going to use this coefficient to predict data in the validation dataset. Start with an equal sign, intercept, but this time fix the intercept by clicking function F4, plus slope, fix the slope, times the age. So this is my first prediction. This is the predicted probability for a 39-year-old customer to purchase a product. And we can drag down this, and you can find all the probabilities based on linear probability model. For logistic regression, we are going to use data mining. So in order to do logistic regression, we need to first partition the data set. So click on partition, standard partition, and we need to first select the data range. Our data range starts from A1 and then C31, and then click OK. And here first row contains headers, and we are going to select purchase and age, and we are going to use flag as our partition variable, and then click OK. So now we have the partition data set, and you can see that training has 20 records and validation has 10. Once you are in this worksheet, you are going to click on again data mining, classify, and then we choose logistic regression. And here purchase is our output variable, age is under selected variables. We are not going to do anything with record ID, 0.5 success probability, cutoff, and next. We don't need to choose variance covariance matrix, next, and then finish. So now we have the results here. As you see, coefficient estimates are listed here. We need this coefficient estimates. We copy this, and then now let's paste here spatial with numbers, and we are going to use these numbers to predict the validation set. And if you remember, we have the exponential function for prediction, which is intercept, and I need to fix the intercept function F4, plus the slope coefficient function F4 times age. Close the parentheses, divide 1 plus exponential intercept and function F4 plus age function F4 times again age. Close the parentheses one more time and enter. So this is the predicted probability by logistic regression. We can drag down this formula now for prediction. So we have all these predicted probabilities by logistic regression. Now we are going to calculate y hat first, because these are the probabilities, but we need to find out whether it's 0 or 1. And cutoff value is 0.5, so any predicted probability below 0.5, the customer is not going to buy. Any probability above 0.5, the customer is going to purchase a product from this store. So we use if function. If this predicted probability greater than equal to 0.5, then it's 1, otherwise it's 0. And we can drag down this. And we will just do the same thing for logistic regression. If function, if this predicted probability greater than equal to 0.5, then it's 1, otherwise 0. And we drag down this formula too. So let's compare. These are the actual values, okay? And these are our predictions. So when you look at this table, you realize that 9 out of 10 observations are accurately predicted. Okay, so when we talk about accuracy rate, 9 of them are the same as actual, 0, 0, 0 for both models, but the last one predicted incorrectly by both models because the last observation purchased the product, but the predicted probabilities are less than 0.5. So the both models estimate that the person is not going to purchase this product. So the accuracy rate is 9 out of 10, or if you turn this into percentage, 90%. The same is true for 9 out of 10 or 90%. This is how you use the holdout method for logistic regression and linear probability model.